Hey there. I thought I'd make a short video today about significant digits and making sure we understand it in case what we did in class was a little bit confusing. So, significant digits are also called significant figures, and they are also known as sig figs. So, when do we use them? Well, whenever we're rounding numbers and we have to decide how precise we want to be, because now that we know about irrational numbers, we could have decimals that go on forever, and we need to decide when to stop. So, we'll use significant digits, and you'll see in the book, or myself, or a scientist will tell you, okay, only give me three significant digits, or four significant digits, whatever it is, or even just one. We don't need to go on forever with these repeating decimals or non repeating decimals. We also use it when measuring, just depends how specific our tool is. So the five rules that we have here for when digits are counted as significant are as follows. Number one, not zeros. Anything that's not a zero. So 3, 4, 3, 5, 6, 1, 2, we'd count all of them. 1, 2, 3, 4, 5 significant digits. Okay, now the rest of these are all when does zero count and when does it not. If it's trapped in between non zeros, it counts. If it trails at the end of a decimal, it makes it more precise. So this would be like if we had a scale and we measured something and it was exactly 2.500. So we would count those because it's showing us how precise we are. We use this a lot in science. To the left of the number, those zeros aren't very helpful when we're measuring. So if we want to know the first three significant figures, I wouldn't say 1, 2, 3, right? Or putting zeros in front of it doesn't really help us. So finding three significant digits, we would go down here, 1, 2, 3. And then for numbers like 600, whole numbers with trailing zeros, it depends. So when we get to rounding, we're going to see when it depends. Okay, we did this in class often. Let's look at the rules and do some practice problems. You can skip ahead if you want, but I have some good word problems to show you. Okay, so let's count this, round it to the given number of significant digits. If we want four sig figs, I'm not going to count these first ones because those are leading. So ignoring the beginning digits, I would go 1, 2, 3, 4. So if I'm rounding to that, I know it's definitely going to be 0.00914. It's either going to be 9140 or 9141. Let's think. Look at the digit to the right of it. It's a 7. That means we're going to round up. So the four significant digits we would use is 9141. Okay? What about this one? We want five significant digits. Well, I'm going to, of course, count these two. So that's the first two significant digits. And these are trapped, so I'm going to include those. Right? I can't say that it's because that's not the number. It's actually almost exactly 24. So I would need to put 24.00. And the last one, maybe it's a 9, but let's look at the digit to round. That's a 6. Uh-oh. We can't actually make this 24.09. It actually rounds up. Instead of 9 thousandths, it's 10 thousandths. So this would be 1, 2, 3, 4, 5 significant digits. Okay, something else. Here's an example of when this would be useful. If we want to find like the area of a very specific measured circle, and do you remember the formula for area of a circle? Area equals pi r squared. And the radius here is 2.53. So if we square that, we get pi times 6.4009. And it says to use the approximation of 3.14. So we're going to multiply that times 3.14. And we get a long decimal. So 2.098826. This is getting very far. You know, in fifth grade, we only went to the thousandths place. So if we want to know the area of that circle to just three significant digits, Just go in order. First is 2, then is 0. And then is it 0? Would it be 20.0? Let's take a look at the fourth digit here. That's a 9. So it's not going to be 20.0. It's actually going to be 20.1. So as you can see here, sig figs or significant digits help us know when we can stop, right? We don't need to keep on going. This is not very useful. It doesn't mean as much as 20.1 square centimeters. Some other ones, let's just jump in. I'm going to try and do this just for a couple more minutes. How many significant digits? Well, this is precise. It's not just 600, it's exactly 600. So this would be 4. 1, 2, 3, 4. Here, these are leading zeros. So I don't count those. This would be 2. We don't count this leading 0, but we do count the trapped one in between. And definitely 3, but look, we have 2 more, which make it precise in a decimal. So that's actually 5. All of these count 4. 1, 2, 3, 4, 5. Those are trapped zeros, they count. The leading zeros don't count, but the ones at the end of a decimal do because it makes it precise. And these are trapped zeros. We count them 1, 2, 3, 4. Okay. Let's round to each number to the given. All right, if we want 4 significant digits, that's 1, 2, 3, 4. So it's definitely going to be 3, 5, 0, 2. Or is it 3, 5, 0, 3? Let's look. This is a 1. That's going to stay a 2. Now, would I stop there and say it's 3,502? No, that's not 3,000. That's 350,000. So now I'll change those to be zeros. And that would be rounded to 1, 2, 3, 4 significant digits. Okay, so there's some good practice problems here. I really like this one, number 25. You could use Desmos to actually do it for you, and it would be a really long number. So check that out and use the rules in your notes to give it a try, and then I can show you the more answers another time. Take care.